Right, simplifying radicals simply means to pull out any pairs of numbers, or if it's a cube, any cubes. So in this case we want to pull out any pairs of numbers. So I'm going to factor tree it. So I now have 2 times 2 times 2 times 2 times 2, and I have x times x times x times x times x times x, 2, 3, 4, 5, 6, 7, 8, and that is what it simplifies to once I take out the pairs. So there's a pair of 2's, there's a pair of 2's, pair of x, 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 and x. So 2 2's come out, which is 4. 4 x's come out, and what's left over is the radical 2. And I've simplified that problem. Let's do the next one, but this time I'm looking for 4. So I'm still going to factor tree, and I get 4 2's, so 1 comes out. If I look at the 24, if I divide that by 4, I get 6, so 6 A's will come out. And if I look at 13, 4 goes into that 3 times, with 1 left over, and so the 1 left over stays in the radical. So basically all we're doing is finding pairs or 4's or whatever the root may be. To do a division problem, here's a division problem, we're going to have to rationalize the denominators because we can't have a radical in the denominator. So I'm going to write it as 2 separate so I know what part I'm rationalizing. And rationalizing just simply means, how do I get rid of this one radical sign? Well, to get rid of that one radical sign, I need another pair of y7's. So if I write y7, I have a pair. Pair means the y7 will come out of the radical. But if I'm going to do that, I must do that to both the top and the bottom. So I'm going to do the same thing on the top, which leaves me with x to the 6th times y to the 7th. Now I can simplify the top part. By simplifying, I can take out any pairs of x's or y's. Well, I have 3 pairs here, 3 pairs, and I also have 3 pairs of y, but I have 1 left over. And then I still have a y to the 7th on the denominator. Now this goes back to, okay, we have this, and this is all factors. I have 7 of them on the denominator, I have 3 on the numerator. The 3 can cancel out with 3 of them here, which will leave me with 3 on the denominator. Now to do this one, I'm going to do the same thing, except now I have a 4th root. So I'm going to split 6 to the 4th root and 5x to the 4th root. And by doing that, I now need something to the 4th root. 4 of these. Well, I have 1, so I need 3 more of them. So I'm just going to write cubed. And I'm going to do the same thing to the top. Now what that does to the denominator is the 5x comes out. That's pretty simple. That's why we're doing this. So the next part is we need to finish this problem up. So by doing that, 5 to the 3rd power, this right here, is 125. And 125 times 6 is... So if I have 3 5's and 1 6, if I multiply them up, I will get 750. And then the x would be x cubed. This is the 4th root. Now I know I don't have 4 x's because it says x cubed. And I only have 3 5's in this problem, so I don't have 4 of them. So this is the simplified answer. Okay, to multiply radicals, we just need to have the same root, which they both have root of 3. So we can multiply the 5 times the 3, because they're on the outside. Then we can multiply what's inside the radical, and by doing that, 12 times, or negative 12 times 18, is negative 216. And then the a, pi times a squared, is a cubed because we had exponents, and b4 times b squared is b to the 6th. Now we have to rationalize, or not rationalize, but simplify the radical. Now this negative looks like it would be a I, but it's not because we have an odd number. That means we can have a negative number as long as it's an odd root. So let's go and do our factor tree. If we do our factor tree, that would be a negative 2, positive 108. This would be 2 and 54. It's 2 and 27, 3, 9, 3, and 3. So we're looking at 3 numbers. So we have 3 2's, and they're negative, and we have 3 3's. So if we pull them out with our 15, I have a negative 2, I have a positive 3, I have 3 A's, and I have 6 B's, but 3 goes into that 2 times, so I have 2. So if I finish up the math, this will actually end up as a negative 90 AB squared. And so there it is multiplied. To add and subtract radicals, these two numbers need to be identical, which they're not in this case. So we can make them identical by simplifying. So I'm going to simplify the 98 by finding pairs of numbers. So a 7 comes out, and the 2 stays in. And then I'm going to simplify this one. And I'm going to, that's an 8, 2 and 4, 2 and 2. So I find a pair of 2's, another pair of 2's, and there's already 2 on the outside. So 2 times 2 times 2 gives me a minus 8. And the radical 2, which is what's left over right here, this one stays in. So the pairs come out. So it's just simplified. Now I can subtract. 7 minus 8 is a negative 1. And the radical signs stay exactly the same, just like if they were variables. So if I had 7x minus 8x, I would get negative 1x. Similar to radicals, but they must be the same to be able to add or subtract. And they are. And we got that by simplifying. Here's another version of multiplication. In this case, we're going to do FOIL, or we're going to distribute. So if I take this and multiply by this, I would multiply the outside times the outside, which is 12. The inside times the inside, which is radical 6. Then I can take this times this. Once again, it's outside times the outside, and there is no other radical 3, so it stays the same. Then I'm going to take and multiply each of these. So outside times outside, and inside times inside, and then I multiply by the other number, and I get this. So anytime you have a number outside a radical or doesn't have a radical, they get multiplied, and the radicals get multiplied. And so I end up with this long number. Now with this, I can simplify or add like terms. So if I look, I don't have anything that's alike, but I can simplify. So this simplifies by doing a factor tree of 2 and 2. So the 2 actually comes out. So this becomes 30 without a radical sign. And we don't have anything else that's alike. So our answer then is 30 plus 12 radical 6 minus 24 radical 3 minus 30 radical 2. Because none of them have the same radical, we can't add them. And this one we simplified. And none of these can be simplified because there's no pairs in any one of those. So this would be our answer. But the key to this is multiplying using FOIL. Alright, this last example is conjugating or rationalizing a denominator. So here we have 2 radical 5 minus 1. So basically we have to get rid of the radical sign. To do that, we need another radical 5 to be multiplied. By doing that, that would get rid of the 5 because we have a pair of 5's. But because this minus 1, we need to also get rid of it, so we have to do the opposite of it. Once again, if you're going to multiply the denominator by that, you must also multiply the numerator. So this problem becomes 5 minus 1, that's the denominator. Basically, it's this times this, which there's a pair of 5's, so that's why it comes out of the radical, and a negative 1 times a positive 1 gives us the negative 1, which will get our denominator as 4. Now the numerator is the distributive property in this case, so I'm going to multiply 2 times radical 5, and then 2 times 1. And nothing can be added because there's no like terms, and nothing can be simplified. So we put it over the denominator, which is 4, so we've rationalized the denominator.